Hi. So I hope everyone enjoyed Ophir's talk, and I think if there's something that we can see from everything that Ophir said, it's that it is possible to make React Native work fast. But we have to do something. It's not going to be automatically. The React Native adds a lot of abstractions. It adds a lot of things that a lot of mobile devs aren't normally used to. So there's a little bit of extra work, but as soon as you do that, it can be as fast as you want. And the key thing, especially with working with React Native, but with every framework, is to measure. You need to measure everything. If you don't measure, you don't know where your problems are. You don't know if you're improving the right things. It's okay if you're working on your logic and you're improving everything and you've got all your algorithms down to, you started at O(n) squared and you move everything down. But if what's really hurting you in React Native is that you're rendering things too much, or your render's taking too long, or you're doing things in the wrong order, that's not going to help. You need to invest your time on the things that actually matter. And you can't know that without measuring everything. Also, you can start working on something. You start making a prototype. You start making a small project to show off one thing. You run it in isolation. It works great. When you start putting things together, when you start adding it to a real project, things start to slow down. So without actually measuring everything you do, even if it looks great, you're going to run into serious problems. And on React Native, this is more critical. Because of the single thread in JavaScript, you start wasting a few milliseconds here, a few milliseconds there, you end up blocking your thread. Once you do that, your things start losing responsivity, people touch things and wait for a second before they get any feedback, and it's stuff that they're not used to in native. Something with like iOS, where you have a dedicated thread for animation, for an Android, when you also have the separation between the UI threads and everything, you're used to instant feedback. And with React Native, when you've got to go between different threads, if your JavaScript thread is blocked, you're going to really feel that difference. And there's nothing worse than getting to an app where you know that everything works more or less fine, but when you put it all together, there's no one thing which is blocking it, but altogether it starts to feel laggy, it starts to feel unresponsive, and it's really hard to start to improve that when everything you do makes such tiny differences you don't feel it. But if you start from the beginning to do everything right and make sure that every single thing is as performant and does as little work as possible, then you never get to that situation in the first place. So let's think, what can we measure in the React Native app? So the easiest thing to just look at, you have your JavaScript bundle size. This makes a difference when you load the app. As soon as you start your app, all the JavaScript is loaded from memory. And that takes some time. Older phones, it can take longer. There's a lot of stuff that you might have in your bundle that you don't even know is there. You start reducing your size of the bundle, reduce some of the dependencies, and it can make a noticeable difference to the startup time of your app. The app loading time, if you measure it itself, there's not just the bundle size, but there's if you're doing any logic right at the beginning. If you start to import all your code, if you start to import components, you start to import everything, there's not just the loading the bundle into memory, there's also the passing the JavaScript. This can also take a lot of time. You can, as Ophir was showing, and I'll show later, you can really cut down unnecessary renders. If your JavaScript thread is getting stuck, you might not notice it. Your UI thread might be working fine. As soon as you try to do something, it can really slow it down. And this is something that is really easy to cut out. JavaScript thread time. If you're running too much logic on the JavaScript thread and it's not allowing anything to stop it, then you're really going to notice anything more than 100 milliseconds at a time, you'll feel it if someone starts pressing a button or trying to scroll, or you've got an animation on the JavaScript thread. Anything more than 16 milliseconds, you lose a frame. More than 2 frames, you're going to notice. Like I said, frame rate. React Native has an automatic thing where you can pop it up from the menu and it'll show you the JavaScript and the native frame rate. These are important. When they start dropping, it's really easy to see and you feel it. The time it takes to render things, you can measure that once it starts to go more than just a little bit, any extra thing starts to feel it, and you can measure this and cut it out right from the beginning. On Android, there's more native stuff you can look at. If you have a lot of different views with backgrounds, then the GPU is going to have to do a different layer each time. And this can really end up hurting the native performance on the UI thread. You can measure HTTP requests. A bunch of apps do way too many, too heavy, repeat them too often. You can measure everything and cut it out. And there's a lot more stuff that you can measure. You can think of anything specific to your own apps, more general. Anything that you can measure, you can improve. Without measuring, you don't know that you need to improve it. So let's have a quick example. So similar to Orfeo, I've made an example in React Native. Here's the code, here's the app. It's as simple as you can get. It's a simple app. It's got 1,000 items. You can select them, unselect them. It's just a list. Each one has a picture. That's it. Here's the code. The code is, that's it. It's just a list. It gets data, renders it using a React Native flat list. We have the data from the state. The list of selected is in extra data, so it's responsive. If you want to use data from more than one source, flat list won't let you unless you put it in extra data. And the item is really simple, except I meant to have this here, just to show for the example. So you'll probably work out what's the first thing you can fix. And okay, here's the app. It scrolls. It works fine. Everything. If you were just prototyping this, you'd think everything's fine. The scroll is smooth. You start selecting things. It works great. Without measuring things, you think that this is fine. So let's add some quick measuring. So I have in the item. This is just the code. Not really relevant, but what I have here is I count every time there's a render on the screen. And I can use this to, every half a second, just show how many times an item was rendered. So if we load it again, straight away we can see that as soon as the app loads, there's 43 renders. If I tap an item, it goes up to 64. If I start scrolling a little bit and go back up, it pretty soon hits thousands. So it might look like it's going fine, but as soon as you start using it, you can imagine how much time that's taking up on the JavaScript thread. You start doing anything else with this app, you start taking this list component and put it into a real app where you're doing some work, it's going to just slow down. Things are going to not be responsive, animations are going to stop, anything else happening on the bridge is just going to completely stop. So what can we do to fix this? So the first thing people think of is, let's use a pure component. This list item is over here. It's just a component. We can change it to pure component. So let's try that. Let's see what happens when we change that. Change it simply to item 2, which is exactly the same as pure component. And again, we have 43 at the beginning. Tapping changes it. And scrolling pretty quickly goes up to the thousands. And the reason for this is we have an arrow function in the render. Like Ophir said, if you have an arrow function in the render, it's being recreated every time the main render is called. It means that pure component isn't doing any work. Pure component, all it does is it compares all the props that you get every time your props change and shortcuts if they're the same. If you're using arrow functions in your render, and only in the render, everywhere else it's great, then you're going to lose all the functionality of the pure component. So if we take that away, if we take this function, if we just change it to simply a function, and we uncomment it, we have to bind so it knows, because it uses this set state. Simply by doing that and using the pure component, things change. So now at the beginning, instead of in the 40s, it's 20. If you tap something, it only updates that single item. And scrolling, it already looks better. It's hundreds instead of thousands. But even so, pure component isn't going to help you all the time. What if your data is dynamic? What if this is a list? Normally, a list represents an object, but you're not going to want to display the entire object. Normally, your object in a list is representing something that you drill into and you see. For example, a user or a post, you click on it and you drill in and you see the rest of the data. Now, that other data could change, but at the same time, your render isn't going to want to change. So you have two options here. Either I can pass the individual props. I can look at it and say, what exactly do I need here? I need the image. I need the name. I need whether you're selected or not. And you can start to pass individual props. You can cut your object up into lots of little pieces, decide exactly what this item needs to display on the UI, and pass each one. Or you can pass the full object, like we've done here. In this, we just passed the whole item. This is an architectural decision. Like, you can do either one. There's no right or wrong answer. Personally, I prefer doing the second one, but like we see, that causes problems. Why would you like to pass this? Why do I like that one? Because you might want to pass that object on. It helps if that item already exists in the, you have it in your props. You might want to change the UI sometime later, and you don't want to have to go to every single place this is used. It might be used in a bunch of different places and update every place where it's passed. Also, this list can now be completely generic if it just passes objects. There's no need for it to know exactly what structure the data it's going to be passing on to its items is. So that's why I prefer this way. So if we start using dynamic data, so the data at the moment is coming from here, which is just 1,000 items exactly the same. If we go to dynamic data, which is the same 1,000 items with the same 3 props that we're using, exactly the same, but an extra random thing. Now, this is extreme because it's going to change all of them, but you might have data like that. It's an extreme example, but it does represent something real. For example, you could have metadata attached to your objects. You could have the last time you updated it. You could have the time since the last update. You could have all sorts of things which could change a lot in the background that the user doesn't need to know about, but end up really hurting your performance. So let's change this to get the data from dynamic data. And like I said, it could be metadata, it could be updated in the background, it could change all the time. So let's change this. So every second it's going to get new data. But at the same time, nothing, absolutely nothing will change on the screen. But what you can see is, even though like the performance, like before, when tapping something, it only updates once, when scrolling, it's more or less okay, all the time, render's being called, even though it's going to get shortcutted before it hits the native, but still, it's wasting a lot of time. So how would we solve a problem like that, now that we can't use pure component? So the answer is to do exactly what pure component does, but smarter. Pure component just uses the lifecycle event should component update, and there's a very naive approach of comparing the pointers of the props. So let's see if we can make that smarter. So if we go to item 3, it's back to component, it's not pure component. But in should component update, we've got exactly the props that we want to, that we care about. We've got the ID, that's normally something you care about, the name and the image and the selected and the function, which are all the things, the only things that they actually used in the UI, and that random parameter is not. So if we change app to item 3 and refresh, now we can see straight away we're down to 21 at the beginning. Even though the data is changing every second, there's no render happening. A thread's safe. And we can scroll through, and almost exactly the amount of items that we see on the that we've seen on the screen is how many we've rendered. We've seen 34, and it's rendered 50. And the last thing I'm going to show is, which I've used there as well, is initial num to render and window size. If you're using a list, the default, you have these functions, these props that you can pass, which tell React Native exactly how many you want to render at the beginning and how many to render off screen, which helps with the scroll. So here, if you can see, there's 6 items on the screen, so there's no point rendering more than that. If you don't have that, then straight away at the beginning, you start seeing more items than you need, and you can cut that down to help that extra little bit. So you can see you can cut your renders in the orders of magnitude, by 95%, from thousands to just dozens, just by a few extra lines of code and thinking. Yeah. So what tools do we have to measure things? So the first one, what I used here, is just console. By putting console logs everywhere, you can really you can measure exactly what you need. It's very precise. You know what you're doing. It's really, like you can see. The other one is Chrome DevTools. That's also, you can just start it like this, debug.js. You open it here. Here you also have the console, but you also can see what network requests you're doing. You can debug properly with the source. You can see performance in memory. You can record traces and see exactly what you're doing on different threads at the right time. That's probably the easiest tool is built into React Native and Chrome. You also have systrace. Systrace is now built into React Native. You can't do it at the same time as debugging. I don't know why it's not working this time, but it's like if anyone's an Android programmer, from Android native, you have it in the device monitor, and you have it in Android, where you can see exactly also what things happen on what thread at what time. You can line it up with your frames, so you can see if you dropped frames, exactly what functions, on what thread it was that caused you to drop frames at what time. It takes a bit more time, but it's also really useful. You can see everything. At Wix, we have a thing called Detox Instruments. It shows you what your memory usage is. It shows you what requests you make. It can show you very simply what requests, what timeline, how long they took. It shows you different threads, how much work is going on in each thread. Specific for React Native, it shows you what data and how much data is going across the bridge. And it comes with React Native JS Profiler, which we'll talk about more next time, but it also allows you to put things into Detox Instruments to show exactly what you're using. And using that, you can really drill down to what's causing problems, what's taking time, and you can really improve the right things, not just improve everything, but improve the things that are really hurting your performance and make it feel much, much better with minimum changes in the code. And if you just search React Native performance tools, there's tons more. There's Slowlog, which automatically can measure how long each function's taking. There's tons more online, and there'll be another meetup about it next. And you can find the code for this example in my GitHub. Thanks. Any question?